Okay, hello everyone. Okay, so for this part of the video, okay, we'll be going through a homework for cones. Okay, so as usual, I've assigned 5 questions. Okay, for this time is 11, 14, 15, 16, and 18. Okay, so before we begin, just a quick recap. Okay, so as for all other ob- things that we learn in this topic, the main calculations you need to be able to perform will be to calculate the volume and the surface area. Okay, so for cones volume, actually there's nothing new to learn over here because previously you learned in prisms that the volume of prisms is a 1/3 base area times height. Okay, cones is actually also a prism, just that the base is a circle, okay, instead of your polygons. Okay, so in that case the volume will just be 1/3 pi r square times height, since the base area is a circle, pi r square. Okay, then in terms of the surface area, okay, base area plus the lateral faces, in this case it will just be the curved surface area. Okay, so the base area will be pi r square. Okay, the curved surface area we will do pi r l, where l is the slant height, okay, of the cone. Okay, and how do you find slant height? Okay, relating to the height and the radius. Okay, these three lengths are tied together using Pythagoras theorem. Okay, so yeah, these are the main things you should know. So the only new thing, okay, will be your curved surface area, okay, with the formula of pi r l. Okay, so without further ado, let's begin. Okay, let's start with question 11. Okay, so over here, figure 1 and figure 2 show two chocolate pieces. They have the same shape of a pyramid and a cone respectively. So this is a pyramid, this is cone. They tell that the pyramid has square base of side 2 cm and volume of 4 cm cube. The cone has a base radius of 1.2 and the same slant height as the pyramid. So first, I ask you to find the slant height of the pyramid. Okay, so how do you find the slant height for the pyramid? Okay, so over here they have redrawn the diagram nicely for you. Okay, the slant height that it refers to is VP. Okay, so VC is called the slant edge, VP is the slant height. Okay, so they're asking you to find the slant height. Okay, what are some of the information that we already know? We know that the base area is 12. Is the base has a side of 2 and it's a square, so this means this is 2, this is also 2. The volume is 4 cm cube. Using the volume, okay, we're able to find the vertical height, okay, because the volume is 1/3 base area times height. Okay, so with that, okay, so 1/3 base area times height, we know that the volume is 4, base area will just be 2 times 2. Okay, so you do the substitution, then you can find your height, which should be 3. Okay, so this means that VO is 3. So now VO is 3, OP is half of AB. Okay, so that will just be 1. Okay, so if you know that the height is 3, the radius is 1, you can find the slant height using Pythagoras theorem. Okay, so where your slant height is your hypotenuse. So you apply Pythagoras theorem, make sure that this you do specifically say that this is by Pythagoras theorem to show that your understanding in this, okay, it does not come out of nowhere. And yeah, so VP square will just be 3 square plus 1 square, okay, which is 10. So then you just take the square root, okay, you should get VP to about 3.16. So the slant height is 3.16 cm. Okay, just repeat again. So when you're doing Pythagoras theorem, other than remembering to write by Pythagoras theorem, okay, also do remember to indicate that when you take a square root, this is plus minus, okay, and then over here the to reject away the negative. Okay, after you have plus minus to reject away the negative. In this case, since you're taking a square root, this will not be an exact number, so you can correct the answer to 3 significant figures. Okay. Next part of the question, they tell you that the two chocolate pieces are sold at the same price. Determine which piece is a better buy. Okay, so in this case, what should you be looking for? There's volume, there's surface area. Best buy, of course, okay, for the same price, you get more volume, correct? That means that you get more chocolate, okay? So to get more volume, okay, you know that the volume of the pyramid is already 4 cm cubed. So what do you need to do? You need to calculate the volume of the cone. And if the volume of the cone is larger than 4, this means that, okay, the cone is a better buy. If the volume of the cone is smaller, okay, then this will be, the pyramid will be a better buy. Okay, so how do we find the volume of the cone? They say that, okay, so the cone has the same slant height as pyramid, so we know that this is the same as here. Okay, the base I know is 1.2. So to find the volume, 1/3 base area times height. Okay, so I know 1.2, which is my pi r square. I can find my base area, but I don't know my vertical height. Okay, so I need to do another round of Pythagoras theorem since I know the slant height is the same over here. Okay, using the slant height 1.2, I can find my vertical height. Okay, so that's what we're going to do. Okay, so over here, they did it out nicely for you. The slant height, okay, they carry over from here using square root 10. Okay, you use the value before it's rounded off so that you get a more exact one. Okay, so here's 1.2. You can find your xm, okay, using Pythagoras theorem. Same thing, always state your Pythagoras theorem, do your substitution in. So this is why we want to use square root of 10 instead of using 3.16. Okay, if you do a 3.16 square, you'll get something close to 10 but not exactly 10. Okay, so but when you square the square root of 10, you get back exactly 10. Okay, so there's no loss in the accuracy. Okay, so after you do a substitution, just do some shifting, your usual algebra. Okay, xm is square root of 8.56 cm. Okay, same thing, remember to do a plus minus and to reject the negative. So now you know the vertical height, you are ready to find the volume of the cone, which we say is 1/3 pi r square times height. Okay, so my r is 1.2, my h is square root of 8.56. Okay, so 1/3 pi 1.2 square root of 8.56. Okay, then you just key into your calculator, you get 4.41. So you don't just stop there. Okay, in this case, if you just stop here, okay, you will not get a full credit for this question. Okay, because the question asks you specifically which piece is a better buy. So if you just stop over here, you have not concluded, okay, whether which piece is the better buy. So in this case, since the cone has a larger volume of 4.41, okay, compared to pyramid, which is only 4, okay, so yeah, the cone chocolate piece would be a better buy. Okay. Okay, next we have question 14. Okay, so in the diagram, ABCD represents a bucket, okay, which is shaped like a frustum, okay, of a cone. Okay, a frustum is actually a cone or a pyramid with, the top chopped off. Okay, so it's like a part of a cone or part of a pyramid. Okay, the height of the bucket is 48 cm. Okay, the rim and the base of the bucket has circle with radius 30 cm and 10 cm respectively. Okay, and over here they tell that this is 24. Ask you to calculate the volume of water needed to fill the bucket completely. So how do you approach this type of question? Okay, when it's not just a cone or not just a pyramid, okay, you are having some figure that's not as usual. Okay, two approaches. If the figure, okay, is made out of a few things combined together, okay, then you calculate each of them separately and add them together. Okay, but if your object, okay, is actually made out of something but with a smaller part being chopped off, then you calculate the bigger one, subtract away the smaller one to find the final, which in this case, that is the second scenario. So basically this cone, okay, you find the area of the bigger cone, ABE, then you subtract away the volume of the bigger cone, ABE, subtract away the volume of the smaller cone, DCE. Okay, then you can find the volume of the bucket. So let's proceed with that. 1/3 pi r square h. So the larger one will be 1/3 pi 30 square, and my h will be 48 plus 24, okay, which is 72. Okay, minus away 1/3 pi 10 square, okay, times 24. Okay, so let's look at this. So yeah, so this is the first one, 1/3 pi 30 square times 72, 1/3 pi 10 square times 24. Once you have these two, okay, you can subtract them. Okay, in this case, same thing, they did not straight away calculate out the pi, okay, because pi is an irrational number. There's a long string of numbers with it, and when you do any calculations, there will be some rounding off, the accuracy may be affected. Okay, so but if you keep this, then you'll be the most accurate. Okay, you get 20,800 pi. Okay, multiply by your 3.14 and so on, you should get about 65,300 cm cube. Take note this volume. Okay, so your unit should be cm cube, not cm square, not cm. Okay, and yeah, of course pi is not irrational, so you always correct to 3SF. Okay, just use the pi value from the calculator. Okay, next, part B, the area of the material needed to make the bucket. Okay, so basically to make this, what are the area you need? Okay, you need the curved surface area, the side, you need the base. Okay, you don't need the top, because if you seal off the top, then how does the water go in? Okay, so this is where the type of question you need to be very careful, okay, to interpret what do you need to calculate, so that you don't always just calculate the base area, okay, especially for surface areas. Okay, some people will need to be clear on when to include in this base area. Okay, so same thing, to find this curved surface area, I will take the bigger curved surface area, subtract the smaller curved surface area, then add in the small base area. Okay, so let's get to that. Okay, so to find your curved surface area, okay, you will need pi RL. Okay, L means the slant height. Okay, I know my R. Okay, I don't know my L. Okay, so I need to find my slant height, okay, which I need to apply Pythagoras theorem, okay, with this as my right angled triangle. Okay, so my height I know, my radius I know, I need to find the slant height. Okay, so this slant height will just be this square plus this square equals to this square, so Pythagoras theorem. Okay, so they do the slant height for both. Okay, so EAB is this one. First they find for this, okay, using 30 square and 48 plus 24 square. The other one they use 10 square and 24 square. Okay, so of course they skip quite a couple of steps. Over here you should always write down that this is by Pythagoras theorem. Okay, and to do your plus minus and reject the negative. Once you have the slant height, you are ready to find the curved surface area. Okay, so you can take the curved surface area of the bigger one, subtract by the smaller one. So pi RL, pi 3078, pi RL, pi 2610. So other than this curved surface area, you need this base, okay, of this circle, okay, to be the base of the bucket. Okay, so it's pi r square, so pi 10 square. Key everything into a calculator. Okay, before that, of course, you can calculate out without the pi to have a more accurate value. Okay, but of course the mean answer will be 6850 cm squared. Take note, this area, so it should be cm squared, not cm, not cm cube. Okay, let's move on to the next question. Okay, question 15. Okay, so over here it shows a nail. The body of the nail is a cylinder, okay, of height 25 mm and base diameter 4 mm. Okay, the tip of the is a cone of height 5 mm. The head, okay, is a cylinder with a base diameter of 8 mm and is 2 mm thick. Ask you to find the volume. So this is where actually you have three different things pieced up together. Okay, so in that case, you can find a cylinder, and a cone. So for volume of cone, 1/3 pi r square h. H is 5. My r is just half of 4, which is 2. Cylinders, okay, we use pi r square h, basically your base area times height. So in this case, my base areas are circles. Okay, so in this case, for this one over here, my pi r square will be pi 2 square. Okay, pi 2 square times 25. This cylinder over here will be pi 4 square. Okay, because the radius is half of this diameter. So pi 4 square times 2. Okay, so this is the volume of head, body, tip. Head, like we said, pi 4 square times 2. Okay, body, pi 2 square times 25. And the tip, okay, so 1/3 pi r square h, 1/3 pi 2 square h. Okay, everything in the calculator, you should get about 436 mm cube. Next, they ask you to find the total surface of the nail. Okay, so for the cone, okay, you just need to find the curved surface. You know, to add in the base area. Okay, since it is blocked off. For this cylinder, you only need to find the curved surface also around the side. Okay, don't need to find the 2 circles at the start and end. For this head, okay, you need to find the surface area for both sides. But over here, you take the bigger circle minus away the smaller circle. Okay, so yep. So total surface area of the head, okay, minus away the base area of the body. So the total surface area here minus away the smaller part here. Then curved surface area of the body, curved surface area of the tip. Okay, quite a lot of calculations over here. Okay, so let's go through them a little step by step. Okay, so first over here I have 2 pi times 4 times 2. Okay, where is this 2 pi times 4 times 2? This is actually the curved surface area of the head. Okay, so over here 2 is the height. Okay, how do you find the curved surface area of a cylinder? Okay, you use the diameter, okay, multiply by the height. Can you imagine that the curved surface area will open up is just a rectangle. Okay, a rectangle with a height of 2 and the length of its circumference. Okay, so circumference, usually we use 2 pi r. Okay, so in this case my r is 4. Okay, so my r is 4. So 2 pi r, which is my r is 4. Okay, then times 2, which is the height. So it is the curved surface area of the head. Okay, then of course that's just the curved surface area. You also need to take note of the two the circles here. So this is pi 4 square minus pi 2 square. Okay, the bigger circle minus the smaller circle. So minus pi 2 square. Okay, how come there's 2 of these pi 4 square? Is because, okay, they are trying to account for this side of the head and the green side that you see over here. Okay, then after that you go to this curved surface area. So same thing, the circumference multiplied by the height. So the circumference, okay, will be 2 pi r. So in this case my r is 2. So 2 pi 2 times 25. So 2 pi 2 times 25. Okay, last one is your cone. Cone surface area will be pi rl. Okay, so in this case r is 2. That's settled. Okay, l is the thing that you don't know. Okay, because you only know that the height here is 5. You still don't know the slant height. Okay, so this is where Pythagoras theorem can kick in. Okay, so pi rl, r is 2, l, okay, you can take the square root of the sum of the other two squares. Okay, and the total surface area of the nail is about 486 millimeters square. Okay, and that's for question 15. Okay, so it's still a pretty straightforward, just a more tedious question. Okay, a cylindrical container, okay, of base radius 8 cm is filled with water to a depth of 10 cm. Okay, so over here, this is a cylinder, okay, 8 cm, filled all the way up to 10 cm. Find in terms of pi the wet surface area of the container. So wet surface area of this container will just be the surroundings at the side and also the base. Okay, in this case, in the story, the cone is not at the in yet. Okay, so you can ignore the cone. So it will just be a curved surface at the side plus the base. Okay, so how do you find there's B part 1 and part 2, sorry. Okay, so yeah, the wet surface area. So to find this curved surface, just now we just discussed, if you open it up, this is a rectangle with the length as the circumference of the rectangle or the circle. Okay, and then H is over here. So we said that the H is 10 cm. Okay, so we know this is 10. Then this is your 2 pi r. So where r is 8. Okay, so 2 pi r, then 10. Okay. Then of course you have your base area pi r square, so pi 8 square. Okay, into a calculator, okay, you should get about 224. Okay. Pi cm square. Next we move to part B. Solid right circular cone of base radius 6 cm and height h cm is immersed in the water. So you can see over here it goes in. Okay, the water in the container covers the cone completely with its vertex exactly below the water surface. So meaning the height of this is just nice. Okay. Ask you to find the volume of the value of h. Okay, so in this case, this h, wow, okay, that's not so straightforward to find. A few things you need to take note of. Okay, previously it was at 10 cm. Okay, so some of you might think, oh, the depth is 10 cm, so h must be 10. Okay, but remember previously this cone was not added in yet. Okay, so once you add in this cone, the height actually increases. Okay. Okay, so over here we begin total volume of water and cone, just, yeah, cone plus water. Okay, so over here you do all your substitutions. Total volume of water and cone would be, okay, the volume of this whole thing. So you can just calculate the volume of this whole cylinder. This will be water and cone. So in this case, I will be pi 8 square times h. Okay, so that will be my volume of the water and cone. So pi 8 square times h. Volume of cone, 1/3 pi 6 square times h. So 1/3 pi 6 square times h. Then there's also a pi times 8 square times 10. That's the original volume of water, okay, before you add in the cone. Okay, so that's the volume of cone where the h is 10. So pi r square, so pi 8 square times 10. Okay, so once you have this, now you have formed the equation. You need to solve for h. So you do some simplification. Okay, expand this out, keep things in pi h. So all the pi h will go on to one side. Okay, then you take 52 pi to divide on both sides. So h is 640 pi divided by 52 pi. Okay, we should get about 12.3. Okay. Next, find the total surface area of the cone. So you need a curved surface area and probably a base surface area too. So you need a pi RL. So R is already 6. L is what you need. Okay. Okay, now you know that H is 12.3. You let L be the slant height. Okay, so L square equals to this square plus 6 square. Okay, so key into a calculator, you get that. Of course, you need to apply a Pythagoras theorem, which they missed out over here. So take note, okay, do right by Pythagoras theorem, do your plus minus, okay, and reject the negative. Okay, so once you have the slant height, you are ready, okay, to find this curved surface area using your pi RL. Okay, so your pi RL will be pi, R is 6, L is 13.69 possible. Key in square root of 187.48, you get a more exact value. Okay, and then of course you still have your base at pi r squared, so pi 6 squared. Okay, add them together, key into a calculator, you should get about 371 cm squared. Okay, otherwise we are ready, okay, for, I believe it should be the last question. Question 18. Okay, so in this diagram, V is the center of a circle, okay, with radius 10. Okay, the length of the arc ACB is 12 pi. Okay, the sector VACB, okay, is folded such that the VA just touches the VB, okay, to form a right circular cone. So they ask you to find the base radius of this cone. Okay, so you need to do some calculations. You need to know that this, okay, when it folds up, this is where you get a cone. So your radius here of 10, when it folds up, it becomes the slant height. Okay, so over here, first they let RCM be the base radius of the cone. Okay, so your base area of the cone will be equals to this 12 pi. Okay, because, okay, maybe let me draw. Okay, here they never include the diagram. Okay, it's okay. Okay, so if I draw this out, you can imagine that this is my cone. Okay, so my VA, VB touch each other, so it'll be here. This means that, okay, this, they are all the same. Okay, at 10. Okay, whereas when this touches this, this will be my this. Okay, so basically I ask you to find the base radius here. So this 2 pi r, the circumference here, must be equals to this green part, which is 12 pi. So your pi and pi cancel out, your r should be 6. Okay, next we do the height. Okay, if you know the base radius is 6, okay, you know the slant height is 10, you can do the height. Okay, so 10 square is a hypotenuse. Okay, then you take 8 minus away another random side. Remember to always write by Pythagoras theorem. When you're doing square root, make sure you have plus minus. So h should be 8. Okay, part C, the curved surface area. Basically, this surface area you should know is pi RL. Okay, you know that R is 6. You know that L is 10. Okay, that's all you need to know. Pi RL, pi times 6 times 10. 60 pi is about 188 cm squared. Okay, last one, the volume of the cone. So how do you find this volume? So 1/3 base area times height. Okay, my base area will just be pi r square in this case. Where was it? Okay, never mind, I just press first. Okay, so 1/3 pi r squared times h. Okay, so we have found the h over here, 8 cm. Okay, so the height of the cone is 8 cm. Okay, don't have a diagram, but yeah, the height of the cone. Then you just key into a calculator, you should get about 302 cm cubed. Okay, if not, that should be all. Any questions, any part that I went a little fast or you're not very sure, okay, just let me know. Okay, thank you, bye bye.